Hello everyone. Have you ever thought about how to do statistics with Excel? I'm sure many of you must have thought about it, must have tried doing it as well. In today's lecture, I'm going to share a sample data set. We have few questions that the organization has asked about that data, and we have to use statistical tests to recommend what we are recommending at a particular confidence interval. So let us start. Our sample data is has following variables. It has monthly income, overtime worked or not, so if the employee has worked overtime or not. Business travel, wherein we have three levels. If the person or employee traveled for business frequently, traveled for business rarely, or did not travel. And then finally, we have a variable for attrition. If the employee is an attrited employee or is he still with the organization? Considering these four variables, suppose organization wants to know the following three questions. First, if the monthly income is impacted by overtime and employee does. If monthly income is impacted by the business travel. And the third question the organization wants to answer, if attrition or is attrition increasing because of low monthly income. Now let us see how to solve this. What I'm going to do is show you a sample data and then take one question at a time. For every question or every use case, we need to have a very definite hypothesis. And as we know, hypothesis is written in null and the alternate version. So I'll share for the first statement, how can we write the hypothesis? If the question is whether monthly income is impacted by overtime and employee does, our null hypothesis in this case will be average monthly income for population that does overtime is equal to average monthly income of those who don't do overtime. And the alternate hypothesis will be the reverse of this statement, which will be average monthly income for population that does overtime is not equal to average monthly income of those who don't do overtime. Overtime variable has two levels as shared, yes and no. We are going to use these two samples of those employees who are doing overtime versus samples of those employees who are not doing overtime. The type of test that we are going to use would be two sample t-test assuming unequal variance. Now, because we are dealing with two samples here, we would do two sample t-test. Assuming unequal variance, variance is something that we have not checked and we are not going to assume here that it is equal. So we will assume unequal variance. Kind of test is two sample t-test. However, we are testing for two tail because our alternate hypothesis has inequality to be tested, which can either be on either side of the tail. It could be either on the left side or the right side. So let us see how we can solve this question in Excel. This is the data set that we are going to use. We have the data set in four columns. I have monthly income. Second column is for whether the person worked overtime or not. The third column is for business travel, and we have three different levels as shared earlier. The fourth column has attrition information. We have some employees who were attrited and some employees who are still with the organization. Now, when we want to do an analysis on overtime, here is where I have captured the monthly income for people who have done overtime versus people who have not done overtime. And this information capture is pretty simple. In case you want to do it on your own, you can just filter by yes, copy these samples in this cell, and then flip it back to overtime no, copy the monthly income and paste it in this cell. So we have several samples of the employees who have done overtime and several samples of the people who have not done overtime. Now, if you want to do the t-test for two samples assuming unequal variances, you would click on data. There is an option that says data analysis. In data analysis, you have the option of the test which says t-test, two sample assuming unequal variances. You'll click OK. You'll have to select the input one range. So the first range will be the monthly income of the people who did overtime. The second range will be monthly income of the people who did not do overtime. Every hypothesis is tested at a particular risk level, and that risk, unless otherwise stated by the organization, can be considered safely to be 5%, which means that any of the tests that we are doing, any of our recommendations that we are sharing, will be true up to 95%. 5%, there is a likelihood that our assumption, our recommendation may go wrong. And this is established fact. It is a known fact that we take risk of about 5%. So whatever we recommend is compared against the probability value of 5%. I'm going to put the result in a new worksheet fly and I'll quickly hit OK. Now this is the result of two sample assuming unequal variances for the sample where we had employees who did overtime versus employees who did not do overtime. If you see the average of the samples that we had taken, the average monthly income is 6,548 for overtime and 6,510 for no overtime. Overtime group is slightly higher in their monthly salary or monthly income. We have taken same number of samples in both the categories, so sampling is not an issue. But just looking at the mean, we cannot say that the monthly income of the group that does overtime is higher than the monthly income of the group that doesn't do overtime. When we do this kind of test, we have to infer using the p-value. And for this, if you remember, our hypothesis had inequality sign. I'll take you back to the hypothesis. It says average monthly income for population that does overtime is not equal to average monthly income of those who don't do overtime. When we have inequality sign in the alternate hypothesis, we have to do a two-tailed test. That is what I've mentioned here as well. So if you look the p-value for two-tailed test, this is what we have to consider to recommend finally. Now, there is a rule. If P is high, null will fly, and if P is low, null will go. So, as you know, we always reject or fail to reject the null hypothesis. Here, when this probability is compared for the two-tailed, it is compared against an established alpha of 0.05, which is what we used when we were doing RT test. When I compare 0.9 to 0.05, our p-value is higher than alpha. So if p is high, my null will fly. My null hypothesis is going to stay, which means I fail to reject the null hypothesis. And if you remember, our null hypothesis was that monthly income of average monthly income for population that does overtime is equal to average monthly income of those who don't do overtime. Hence, there isn't sufficient evidence to support that population average monthly income differ for those who do overtime versus who don't. This is going to be our conclusion. And this is what we can safely recommend to the organization, that average monthly income doesn't significantly change with the fact if the person is doing overtime or not. And here you saw we just took Excel, did a simple test with the at the base on the basis of the p-value two-tailed, we were able to fail to reject the null hypothesis and we were able to provide a recommendation. Now this recommendation will hold true for 95% of the times the person will take the sample from the same population. Yes, 5% we have assumed risk. 5% we may go wrong, but 95% is a lot many chances out of every 100 that the person would try and would still be able to recommend what you are recommending. This is just one example.